Welcome back to Maths with Mr. Duffield. It's finally happening. I've gotten around to responding to a couple of my Deps who have been asking for help with Radians, specifically this question. Let's have a look. Got a graph of a cosine function and a straight line graph y equals k. The diagram shows part of the curve y equals 2 cos a third x, where x is in radians. I'm just going to put a circle around radians, and the line y equals k. Calculate the x coordinates of the points of intersection of the curves y equals 2 cos a third x and y equals sine a third x. Give your answers in radians, correct to 3 significant figures. Okay. Well, the first thing I'm going to say about this is that the diagram that you've got on the top there, it's kind of a red herring. What a red herring means, generally, in case you don't know, is something that's there and that is interesting, but isn't really relevant, and it's almost a little bit of a distraction. Because listen, if I've got two curves, y equals 2 cos third x and y equals sine third x, they're both equal to y. Therefore, they are equal to each other. Let me show you what I mean. Okay? 2 cos of a third of x is equal to the sine of a third x. Because they're both equal to y, they're both equal to each other. Now, I can rearrange this into a form where I have a single trigonometric identity function. One of the single ones, not sine, not cos in independent places, individual places, but a single trig identity in one place. And I'll do it as follows. Dividing both sides by cos a third x. That eliminates, and I'm left with 2 on the left-hand side. And on the other side, I have sine a third of x over cos a third of x. Yes, you guessed it, 2 equals tan a third of x. Oh no. The diagram above is no longer relevant. I have an equation in tan. Let's take a look at the diagram, shall we? Because it's good to have a diagram representation. The tan graph looks like this. All right? And there are 2 sort of asymptotes that the line will tend to but never quite touch. They're dead vertical. And if we're working in radians, instead of going between 0 and 360 on the x-axis, I'm going between 0 and 2 pi radians. This is halfway through pi. This asymptote is pi over 2. This asymptote is 3 pi over 2. If you are in a position where you don't know how to convert between degrees and radians on this axis, then feel free to go back and look at the previous lesson's work, because that is detailed there. Okay? Now, we're looking for tan third x equaling 2. So 2, somewhere in the positive bit, somewhere up here, right? Dotted line across. I'm looking for intersections here. There's going to be an intersect for here, for one of the solutions, and an intersect here for another of the solutions. I trust that that's making sense. We're dealing with the tan graph here, not the cosine, the cos graph. I mean, this is useful in that it gives you a sense that you're graphing it is a good idea. But this is the graph that we're looking for. Now, let's look for the value that's going to be there, which I'm going to do by doing inverse tan. Inverse tan of 2 is the same as a third of x. Okay? I'm just inversing tanning both sides. Got to make sure that your calculator is set to radians on this, otherwise you're going to get a big fat wrong. A third of x on my calculator is 1.107. Okay? That is this value here. Okay? Sorry, let me just move this down. 1.107 is there. So what is therefore the second intercept here? Well, we need to know how many kind of radians there are between each value here. And the answer to that is that there are pi radians. There's a gap of pi between each of the 2 solutions here. So all I need to do is take that first solution and add pi to it, and I've got my second solution. That is 4.2487. Okay? Those are our values for 1/3 of x, which I need to triple. to come up with x on its own, because I don't want a third of x, I want just x. So I'm going to times each of these values by 3. 1.107 times 3, that makes 3.32. I've rounded it to 3 significant figures because the question tells me to. Okay, and down here, 4.2487 times 3 makes 12.7. Remember, these answers, these numbers are in radians. So what was the trick here? What was the issue? The issue was recognizing that it was tan. As soon as I got to this point, well, the rest was as easy as sketching the function and just understanding how it works and how inverse tans work. I hope that helps you. I appreciate that this stuff is tricky. I mean, look at it, for goodness sake. I wish you all of the best with all of your studies that you're doing. Please, please take care of yourself. Stay positive, for goodness sake. And let me know if you have any more questions. See you later.